Here we go. We got integration by parts. So, integration by substitution is basically a technique for doing the chain rule backwards. Integration by parts is basically doing the product rule backwards. Let's remember the product rule to work out what the parts rule is going to be. The product rule says the derivative of this times this is derivative of the one times leave the other alone plus leave the one alone times derivative of the other. This is the order I've usually been writing it in. Well, an integral is an antiderivative. Every derivative rule I know can become an integral rule. This tells me that the integral of the thing on the right is u times v. And we could make this the integral by parts rule, but it's sort of, the problem is, it's sort of a lot of stars need to line up to use this formula. You need to have this times this and also a corresponding this times this all there to be able to use the formula. If we made the formula, we'd be saying, well, I have this thing and I wish I had this thing, so I'll add it and I'll subtract it, and now these two parts can combine into that, but I'm left with this other thing, and you're going to end up doing that every time. So instead of making you do that in the problem, we do that in the formula. And what that means is we split this up into two separate integrals. Integral of du dx times v plus the integral of dv dx times u is uv. And then we pick one of these to be, if my problem is this, I'll move that to the other side and I'll have a bigger, messier formula for the other thing. So that becomes the integral of u times dv dx. I'm switching the order here. It's multiplication, it doesn't care about order. Equals uv minus the other thing. The integral of v times du dx. This is almost the integral by parts formula, but there's a standard way of writing it, which is pretend the dx's cancel, which doesn't mean much. It's basically making dv act the same way it was in an integral by parts, or in a substitution. I'll show you what that means in a second. This is the usual way of writing the integral by parts formula. You're probably going to want to plan on, you want this memorized. And you're probably going to write it down every time you're doing an integral by parts, because at least if you wrote this down, that's something I can give you points for. I guess on a take-home exam, there's not that, I'm probably not giving that many points for being able to write down the relevant formula. Anyway, let's try this out. The most simple standard example of an integral by parts, if I wanted to integrate x e to the x dx. How do we do an integral by parts? The thing we're doing is our problem is going to be, needs to be read as u dv. And in this case, the correct choice for u is going to be x, and dv is going to be everything else. The thing we have in our integral by parts formula is something times something. This is multiplication. When I'm integrating something times something, that's sort of a sign that integral by parts is probably a good idea. Also note that the dx is part of one of those things, and it's always going to be part of the dv. So whatever I choose, this feels like we're making two choices. I'm picking a u and I'm picking a dv. It's really only one choice. Once I've picked what u is, dv must be everything else. Or once I've picked dv, u must be everything else. It's one choice about how do I divide this up. And here I'm dividing it like that. You're allowed to move the things around. Multiplication shouldn't care about order. So you can sort of move things aside. All these things are going to be the u. These things are going to be the dv. Anyway, this is it. I've chosen this to be u. So u equals x. dv is going to be everything else. dv is e to the x dx. I need to write both of these lines down. The usual thing you do with an integral by parts setup is I've written down what u and dv were. That was my one choice. Now everything else needs to derive from that. Once I've picked u, what is du? This works exactly the same as it did in a substitution. U is x. I think what's du dx du dx is 1. I don't write that, I move the dx to the other side. Du is 1 dx. So du is just dx here. The dv part also works just like it did in a substitution, except I have the dv and I want the v. How do I do that? If dv is e to the x dx, that means v is the integral of e to the x dx. This is the first place your integral by parts can fail, is I need to be able to do this integral. And preferably, I want to be able to do it in one line. This is like one tiny part of a much bigger problem. I'd really rather be able to do this integral right now in my head. If I'm not, I can do a substitution, like this can take 5 pages if I'm willing to spend the 5 pages, but it's going to keep my writing and my thinking more organized if I can do it all in one step. And if I can't do it, like it's sort of bad news if I spend 3 pages trying and then give up. I gotta remember I was in the middle of this problem, not of this problem. You want to keep track of what was I in the middle of. I want to integrate e to the x. Hey, I can do that. It's e to the x. The integral of e to the x is e to the x. Boom. Now I use the parts formula. This was u, this was dv. The integral of u dv equals u times v. What was u? Okay, so this got kind of organized. Usually you want this to be a box. I have 4 statements, half of which came from the other half. Like, this was one decision of what's u, and everything else here fell out of that immediately. U was x, v was e to the x, so integral of u dv is uv minus the integral of v du. I don't need to write the left-hand side. That should be the original problem. It might be worth staring and double-checking. That is u dv, right? I did make everything the u and the dv. This integral equals u times v is x times e to the x minus the integral of v, that's e to the x, du, that's dx. Right. Just like with substitution, the parts part won't do the entire integral for you in one go. The integration by parts will change your integral into a new integral. And if you're making progress, hopefully the new integral is better. Just like with parts, it's worth stopping and taking a second and saying, have I made progress? Am I improving things? Is this an easier problem than the original was? Because I don't have to keep doing this. If the original was better, I could go back to that. Here, this is better. The integral of e to the x is good, and it's something I can do in my head. I get x e to the x minus the integral of e to the x is e to the x plus c. Don't forget your plus c at the end. I guess technically, since I'm subtracting this, you're going to be tempted to put a minus c, because it's minus the whole thing, I guess. Plus a constant and minus a constant mean the same thing. It's this plus any number or this minus any number. The thing you're minusing could have been negative, so whatever. We did it. When you're starting out with an integral by parts, it's a good idea to check your answer by taking a derivative, not just to check your answer, but also to keep the derivative rules straight, and also to get a feel of what it is that an integral by parts is doing. What's the derivative of this? This is x times e to the x. To take the derivative of that, I need the product rule. Derivative of the first is 1, derivative of the second is e to the x. Plus, leave the first alone as x, derivative of the second is e to the x. Before I keep going, stop a second and say, what did I want? I wanted to end up with x e to the x. I did wind up with x e to the x. Hooray! Part of this is the answer. But I got this extra other garbage. I wish that wasn't there. Well, let's keep going with the derivative. Minus, what's the derivative of e to the x? It's e to the x. Derivative of a constant is 0. Aha! Here we see the e to the x that cancels that other e to the x. That plus e to the x and that minus e to the x cancel each other. I'm left with just e to the x that was supposed to be. Yay! And this is the main thing that integral by parts does, is this needs the product rule. One part is going to be the thing you want, the other part is going to be some other garbage that you don't want, and the second integral you're doing is figuring out what is it that's going to cancel the garbage you didn't want. Let's try some more of these.